welcome back. Your dreams were your ticket out. Welcome back to that same old place that you laughed about. Well, the names have all changed since you hung around, but those dreams have remained and they've turned around. Who'd have thought they'd lead ya? Who'd have thought they'd lead ya? Back here where we need ya. Back here where we need ya. Yeah, the tease him a lot, 'cause we got him on the spot. Welcome back. Welcome back. Welcome back. Welcome back.
Welcome back. All right. Give it a stretch. Oh, okay, that's good. Oh, that's good. Oh, that's also good. All right. Welcome back to untilit.works. All right. So for this break, hopefully that last work session was a productive one for you. For this break, I want to take a look. So we looked at this article before in the last cipher, and I'm going to add a link to it again. Let me share my screen. Cool. This one, share. All right. So we talked about some of the new things, some of the new features that came to the web in September 2024, right? And so some of them, the one we spoke about last time was the accordion. Now you can create that with just HTML. You can have detail like little drop downs for like they're little detail icons that are actually. Let me show you. Hold on, real quick. Just do a quick recap. So these here are details elements, right? And with that, you can do like these drop downs and no JavaScript or anything needed. It just handles it on its own. Now, what's cool is that across all major browsers now, see, and when I click both of these, two of these open up. If I wanted to only have one open at a time, you can now do that with this name attribute. If you name all the details elements the same, then only one will open up and no JavaScript or anything needed, because previously you needed JavaScript. So now that's cool. And so another thing, I'm only really interested in the stuff that's like available across all browsers. So this was though. And so now this is pretty cool. The Web Codecs API, right? And I've been dabbling more into like video and audio on the web, like how you can like transform things and do things with it, right? Like all within the browser, because I was doing things where you'd have to like send it off to another place, have it do it, and then bring it back. I'm trying to see if I can make it where it's all in the browser. So for example, like the highlight clips that I've been posting to social media, I'm doing all that in the browser. So I created like a quick application to where I can take the recording of it, put it into like this little application I have, pick some timestamps, and then using FFmpeg Wasm, it cuts out the clips, joins them together, put an intro, put an outro, and then that's what I post onto my social media. Now with this, I think you can maybe take it even further. I think. So I haven't really looked into it too much. I kind of looked at a couple of examples, but I've not really dived into it yet because I've got stuff to work on. So it says Web Codecs API. The Web Codecs API is now supported on desktop in Firefox 130, giving web developers low-level access to the individual frames of a video stream and chunks of audio. So just like how I'm streaming video here, I'm thinking you'd be able to take that and get individual frames, do stuff with it, even the audio, do things with it, and like transform it and then put them back together in a new way, maybe. So if you want maybe like add a tint to it or make the bass lower on the audio or something, I don't know. So this is stuff I'm going to dive into more. So the new interface includes video encoder, video decoder, encoded video chunk, I guess like what to do with the chunk, video frame, which I think is that individual frame, and video color space. So you can, so like I'll say, maybe you can mess around with that color space. Maybe even do like if you have like a green screen behind you, do all that in the browser where you can remove the green screen, put something behind it. That'd be kind of cool. So this API doesn't quite make baseline newly available as it is not supported in Firefox Android, which I'm fine with. So however, there is a Firefox nightly support for Android. So if somebody really wants it, then they can get the Firefox nightly version for Android. Cool. All right, good. So yeah, so I figured let's take a look at it. And so that takes me to here, MDN. So I'm gonna copy and post a link to that. So next to the recording of the video, you'll have a list of links that you can check out. All right, so okay, so this feature is available in dedicated web workers, and they give you more information about that. So like web workers are basically little like projects that run on the side, like on a side thread kind of thing, from what I understand. So not on the main thread, but like a side thread where you can like offload some certain tasks and things, right? So the Web Codecs API gives web developers, okay, basically it's saying the same thing. So it is useful for web applications that require full control over the way media is processed. For example, video or audio editors, which is kind of like what I was talking about, like I'm looking into, and video conferencing. Pretty cool. So, because disclosure, I work at Vonage and we do a lot of like video stuff. And I'm pretty sure maybe in some random meeting I was in, someone may have brought this up. Maybe like it's coming up or something. So I'm not sure. Oh, all right. So now many web APIs use media codecs internally. So for example, the web audio API and the web RTC API, which use a lot of the web RTC, you know what I'm saying? However, these APIs do not allow developers to work with individual frames of a video stream and unmixed chunks of encoded audio or video. All right. So web developers have typically used WebAssembly. So again, like I was saying, I'm using FFmpeg WASM, so WebAssembly there, in order to get around this limitation and to work with media codecs in the browser. However, this requires additional bandwidth to download codecs. Yeah, that's another thing. You have to download the codecs that already exist in the browser to be able to use, like in the WebAssembly or whatever, reducing performance and power efficiency and adding additional development overhead. Now, the clips I make, they go by pretty quickly. You know what I'm saying? So I can't complain with the FFmpeg WASM solution that I have now, but I'm interested to kind of see what else it can do, right? So the Web Codecs API provides access to codecs that are already in the browser. Because you ever notice how like you play a random video and it just works? You didn't have like back in the day, I remember you had to like you'd load a video and it's like, well, it requires this thing, and you have to like download it and you have to like refresh the page to play it or stuff. So it looks like there's stuff already in the browsers. It gives access to raw video frames, chunks of audio data, image decoders, audio and video encoders and decoders. All right. Okay. I still got to figure out what like decoders and encoders really are. I'm not even sure. So processing model. All right. So so they have an asynchronous processing model. So I guess you can do like await for stuff. Each instance of an encoder or decoder maintains an internal independent processing queue. Okay. So you have, I guess you can fire off a bunch of these at once. When queuing a substantial amount of work, it's important to keep this model in mind. So methods named configure, encode, decode, and flush operate asynchronously by appending control messages to the end of the queue, while methods named reset and close synchronously abort all pending work and purge the processing queue. So if you hit like reset or close, that's what's going to do it right then and there. So it's not going to wait for stuff to come back. After reset, more work may be queued following a call to configure, but close, which is what here, is a permanent operation. So close, you're done. You have to spin it up again. Whereas reset just kind of like clears it all out and then starts from fresh again, I guess. So yeah, so methods named flush can be used to wait for the completion of all work that was pending at the time of flush was called. Okay. It should only be called once all desired work is queued. So yeah. So you don't want to call flush in the middle of something while still working. Calling it unnecessarily will affect encoder quality and cause decoders to require the next input to be a keyframe. Okay. Okay. So look out for that. Now demuxing, which I'm not even sure. There is currently no API for demuxing media containers. I don't know if that's splitting apart audio and video. I'm not sure. Developers working with containerized media will need to implement their own or use third-party libraries. See all this stuff? Oh man, I have no clue what it's talking about. MP4 Box JS and JS WebM can be used to demux audio and video data into encoded audio chunk and encoded video chunk objects, respectively. Okay, so MP4, demux audio and video data. Oh, okay, so demux audio that's when they meant respectively. I thought they meant the packages. Okay. And then you have the interfaces here. Cool. You can find out more information about that. Cool. There's that color space thing. So it represents the color space of a video frame. That's pretty cool. So you could probably like get that, manipulate it, and add to it. So again, with the maybe like a green screen or something. So imagine doing all that like in your browser. That'd be kind of cool. That'd be cool. So, all right. So examples. In the following example, frames are returned from a media stream track processor, then encoded. See the full example here, which we're going to take a look at. So basically, what it looks like, so they have this frame counter. And let's see. Okay, so we have the track. So we have the stream, which could be coming from like a webcam or what have you, right? Or like maybe a canvas or something. You get the video tracks for it. You get in the first one. And then you have a media processor, which I've been working on some stuff like that for work. So media stream track processor, been doing that. So you put that track into there so you can process it, right? And then you can get like a reader on it. So then you have this while loop. And so you're going to go through. So when anytime there's something red on the reader, that's the result. And if it's done, you finish. You break out of this while loop. Otherwise, you're going to let the frame equal the value of it, of the result. So I think that's like the individual frame. And then you have the encoder, and you're checking out the queue size of the encoder. Encoder comes from where? Not sure where encoder comes from. That's probably in the actual example. So let's take a look at the actual example that they mentioned, which is this one right here. All right, I'm going to add a link to this so you don't have to worry about it. All right, so video processing with web codecs. All right, so from what I gather, what this thing does, so they talk about a bunch of stuff, so kind of like similar to the other stuff we spoke about. And they talk about the example. So basically, they have like a canvas image map. So this is encoding, right? So you get the source here. So like we saw before, media stream track. So that could be like a video element, or maybe like video from a webcam, which goes to a video element anyway. Either way, so like a video element. Then, or you can do like an image, I guess, and then a canvas. And so from that, you get the video frame. Then you encode it, which is what we saw with the encoder thing. And then that chunk, so that video frame through the encoder becomes an encoded video chunk. And then from that, you can send it to like a storage or to a network. Like I guess if you have like I guess when it says network, maybe like to an endpoint, you know what I'm saying, like a server somewhere. So storage, because one of the examples I think is like you can save it to your local machine. So I think that's what that means. And then network is like on like an API, like a server or something. All right. So it all starts with a video frame. So yeah, so from a image source, like a canvas, image bitmap, or video element, right? So they have this new video frame thing here. And they use that. Okay, yeah. So kind of similar to what they were doing before. So like here's the get tracks. Before it was getting the video tracks. So I guess this is doing both things. And then here's that media track thing again. And then you're getting the reader. And then there's that while loop again. All right. Now, and then this is coming from like a picture or something. So no matter where the videos are coming from, frames can be encoded into encoded video chunks, objects with a video encoder. So what are they going to talk about where the encoder? Oh, so here's the config like we were talking about before. So here's video encoder. You check and see if it's supported. If it is supported, then here's that encoder from before. So you're doing a new one with the initial, which is this here. So the output, you go to handle chunk, which is a function that you're going to have somewhere. And then if there's an error, you console log the error. Maybe put console error there. And here's the config, which is what you're passing into there. So you're checking if, hey, can this browser handle these things? Like with this bit rate, the frame rate, and the width and size, and the codec. Because again, some codecs are already built into the browser. Cool. If it can, cool, do this editor with passing the same configure that we saw before with like a flush and all that other stuff. configure with the config here. So you're checking first. If it is, cool. If not, try something else. All right. So the after the encoder is set up, so it would go back to basically what we saw before. So here's that encoder now. And you're checking the size. If it's more than 2, then you have too many frames in the queue. So we're just going to close out. So they're going to drop the frames, right? So yeah, I guess close means you're done. Where the flush, you can start over, I guess. Otherwise, then you do this, and then you encode it, and then you close that frame out. All right. So finally, it's time to finish the encoding code by writing a function that handles chunks of encoded video as they come out of the encoder. Usually this function would be sending data chunks over the network, like I was saying before, or muxing them into a media container for storage. So like turning them into like another video file or something. Okay. So yeah, so here it is like, hey, I'm going to send this to some server, some endpoint thing. Yeah, so if there is a decoder, cool, you need to configure it, which I don't think they do here. Okay. Cool. All right. And what to do with the actual thing here. So yeah, so you see you're uploading the chunk and then you're giving it a timestamp. So I guess you can like do stuff on the back end to like put it together, I guess. And if at some point you need to make sure all pending encoding requests have been completed, you can call flush. And then wait for its promise right here. Okay. Now going the other way, going from the storage or network to the encoded video chunk, put it in the decoder, you get a video frame, and then you get to a canvas to a video. Cool. So I guess this is maybe if you're like live streaming something, you'll be able to get the encoded chunks, do stuff with it, and all right. All right, cool. A lot of stuff here, which I'm not even sure of yet. And then again, you're checking for it. You're doing the video decoder. Okay. So once the decoder is initialized, you can start feeding in the video chunks. All right, cool. That's what they're doing here. Download video audio chunks. Is that the actual? Oh no, this is what you come up with, I think. And that's why they have that timestamp there. Okay, so that's why I was the timestamps before. So now you can get the timestamps, like the chunks by the timestamp. Okay. All right. And then you have this canvas that you're creating. Well, you're not creating it, but you're getting a reference to it because it's called canvas. Then you get the context. And then here's that handle frame from before. Here's that. Okay. All right. Calculate time until next frame. That's interesting. Okay. And then you render it. All right. Yeah. So based on the frame's timestamp, calculate how much of real time waiting is needed before showing the next frame. Oh. So that's what this is doing here. Interesting. Frame timestamp. Oh, so you do some, okay, base time is equal to 0. Where do you do base time before though? Oh, base time, 0. And then, so then base time is going to become the performance now. It's like what it is now. Then you let the media time, the performance now minus the base time. All right. Then you do some math stuff. Great. Oh, and then you wait. So here's where you actually wait until the next. Interesting. And then you draw it on there. Wow. Holy crap. Okay. And then you immediately schedule rendering of the next frame. That is pretty cool. So this is like building your video here and drawing it together. Oh, that's pretty cool. Okay. Huh. Okay. Never thought about that. Interesting. So then they have this demo here, right? That animation. So what's happening is, so this is the demo here that I have posted here. And of course, Glitch went to sleep on me. But what's happening is it's taking like you see like there's a food item on each side, right? That's randomly selected. So you see it's changed from like the peanut to whatever that is, right? So what it's doing is, so here's the index.html. Here are the different food parts that go on the beginning and end of it here. So you can see we have the camera and the film thing here, right? And then you're adding the food, the random food there. And then you're making it spin. And so you're doing all this to the canvas, right? Which is right here, canvas. And then you have this destination div, right? Container here. So then what you're doing is you're getting this source of this, and then you're making this thing spin, right? So that's that, right? Then what you're doing is you have the request animation frame. But so you have that going, so that's spinning. And then you have this, you're creating this worker now. And then you have this message on message, right? You recreate worker in case of an error. Okay. So if there's an error, yeah, okay. If you get an error, then you start over. All right, cool. But then, all right, so yeah, so then you're getting the source, the document element by ID. So that's the source canvas, which, yeah, see, they called ID source. Cool. So they're getting the stream from it, getting the video tracks like you saw before, the first one. Then here's that media stream processor. Then there's that reader again. And then they're creating another canvas inside of that. Well, it's going to go inside of this disk right here, which was this other one right here. So they're basically taking the canvas and then getting the stuff from this first canvas and doing it off screen, like in the worker, kind of like well, not even in the worker. They're doing this off screen because we'll take a look at that. Yeah, because okay, yeah. So they have the worker here. Oh yeah, and then they're sending in the worker to, so it's off the main thread. That is going to do all this stuff here. So it's basically going to send it to that, right? Because you set the canvas to transfer control to off screen. Cool, and you're passing the off screen into the worker, which is this here. And so there's an error, it'll post the error, and then capture and encode, right? So that's all that stuff is doing, right? So you're same config stuff. And so the same thing as before. It's like reading the frame, doing all that stuff. So all the stuff we saw before. And then here's the decoding part, right? Where then you're giving the which I think this is the first canvas. I think. And then you're handling the frame. And there's that set timeout again. Oh, wait, no, wait, hold on. No, I think this is the destination canvas. Yeah, so you're starting the decoding, and because here's the stuff where like stuff is getting encoded, but then here's this other one where it's being decoded. So this is the destination one, and that was the source one there. Yeah. So yeah, so the handle output, the handle frame joint. So then they have this here, cool, the decoder. And you kind of see like because my computer is going through a lot right now, you can see that this one is kind of like stuttering, whereas this one is going smoothly because this is on the main thread. This one isn't. Otherwise, this one would have been all stuttery and messed up. All right. So yeah, interesting. Cool. Pretty cool. And then, yeah. And then it goes back out. So it sends the message with the frame and all that good stuff. Right. Bam. Then on the message, which is what we get here. And then I guess it goes back to the frame. I still have to look through this, but yeah, that's pretty cool. And yeah, you can check it all out. It's I put everything there, and I'm gonna get y'all back to work because I'm over time because I was kind of like nerding out about this. But this thing is pretty cool. This whole web codecs API thing. So let me know what you think. If you play around with it, let me know what you come up with. And so this might be like the next thing I might mess around with since it's like in a line with the stuff I'm kind of working on already. So might give it a shot, see what I can do with it. All right, I'm stop my screen share. Let me get y'all back to work so I can get back to work. I want to try and see, because right now with my project, I need to be able to, as I'm developing this thing, like work on it locally. And then I want to be able to push to like Cloudflare for right now so I can get that worked out with the environment variables. So right now, things locally are broken because everything is set for Cloudflare. So I need to come up with like a function or something to be able to check whether, hey, it's in development, use this. Oh no, it's probably Cloudflare. For right now, do this. So I want to get that working, and then I'll be able to expand that as I try with other platforms. That is the plan. So we'll see what happens. But yeah, let me get y'all back to work. Again, thanks for hanging out. When we come back, we'll take a look at our website, listen to music, watch some videos. Maybe you'll become a fan. But till then, I'm going to see you 15 minutes after the hour. I wish you much productivity. Thanks for hanging out. This is New Jabez featuring Apani B. The track is called Thank You. Thanks for hanging out. I'll see you around. Y'all be easy. And peace.
But let me start from the heart. I just want to stay. I think all the showing love to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. I thank you all for showing love to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. But let me start from the heart. I just want to stay. I thank you all for showing love to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. I thank you all for showing love to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how.